Okay, here is a little bit more involved proof, but I do want to just mention that this proof could actually be done in 2 steps, depending on the route that you take. The way that we have done it here, we're going to have 4 steps and we'll have 4 reasons to go with those steps. But I do want to mention that 5 and 4 are alternate exterior angles, and so we could use the alternate exterior angles theorem that says if lines are parallel, then alternate exterior angles are congruent, and do this in 2 steps. But I do want to show you this a little bit more involved proof here if we did work it out a different way. So we are given in this one, and this one is nice. It has the given statement, it has the prove statement that we're going for, which is, we want to look at these and make sure we're familiar how would they look. The given statement, you put that first and you put given. Then mark it in your picture this so that A is parallel to B. So these 2 lines are parallel, marking with little arrows on the lines. Our goal is to prove that 5 and 4 are congruent, but like I said, we're going to go a different route than alternate exteriors. So the route that they took on this proof is they went with 5 congruent to 7. They must have noticed that these are corresponding angles and kind of decided to use the corresponding angles and then the vertical angles to get 4 and 7 congruent, and then transitive to link up 5 and 4. So we can work that way through a different type of angle pair. So we're going to say if lines parallel, then corresponding angles are congruent. Because we're just going with their statements, so we're picking the reasons that would match with what they have. The next thing they have is 4 and 7. So when you look at 4 and 7, think of how they're related. These are vertical angles, and we know that vertical angles are congruent. You do need to put vertical angles are congruent, or vert for vertical angles, and the congruent sign. If you don't put congruent sign, it would be marked wrong. Now we notice in our picture, based on our markings, these are the same, and 5 and 7 are the same, so all 3 of them are the same. And so when you want to link up 5 and 4, instead of 5 and 7 and 7 and 4, you're taking out that 7. See how the 7 gets repeated. And so remember, when we're taking out that repeater and linking these up together, that's that transitive property that we learned before. Transitive property. And remember to put either equality or congruence depending on the statement. This one has congruent in the middle, so I'm going to put congruence at the end there. So there is a little bit more involved proof than the ones we did a moment ago. And here is one that's even a little bit longer. So in this particular one, we are given the supplementary pair. And when you're using these supplementary ones, they generally have a little bit longer proof with them. It's just the nature of it when you're dealing with supplementary and vocabulary words and things like that. So 1 and 4 are supplementary is given. There's no marking for 1 and 4 to be marked as supplementary. So I can't really mark in the picture here. So I just have to kind of keep going with it. The 1 and 4, they're not the same side interior pair. So I can't use the fact that they are a same side interior pair to go straight to my parallel line. So I have to find a different route. And so to find that route, what I'm going to have to do is work through, angle addition here, and the fact that supplementary means 180. So we're going from supplementary with this 1 and 4, and we're going to say that is 180. And so that's using the definition of the word supplementary. A lot of the time, if you have a vocabulary word, the next reason that you'll see is using the definition of that. So definition is supplementary angles. And then they're saying that 3 and 4 are supplementary. Well, 3 and 4, we're not coming from these statements up here. So we need to go look at the picture and decide if we agree that 3 and 4 are supplementary. So 3 and 4 are here. They are going to add to 180 because they are a linear pair. And that is the linear pair postulate that says that linear pairs add to 180. So we're going to put linear pair postulate. Then what they are doing is they are, if we notice from 2 and 3 to statement 4, notice how the 180 repeats. And they are taking this measure of angle 1 plus the measure of angle 4, and the fact that this is 180, so here's measure of angle 1 and measure of angle 4, and they know that it's 180, and they're taking out this 180, and they are putting the measure of angle 3 plus the measure of angle 4, and they are linking these two blue ones together, taking out that middle man that was that 180, using that transitive property. In this particular statement, it's an equal sign in the middle, so we'll put transitive property of equality there. The next line, notice it has exactly the same thing on the left side as on the right side. And when that happens, that is always the reflexive property. And in this case, it's equals in the middle, so reflexive property of equality. And then what they did, they made that statement just to kind of make you aware that since they are the same, we can subtract the same thing from both sides of the equation. And by that, I mean we're going to subtract the angle force off of each side, which will leave me with the measure of angle 1 equals the measure of angle 3. So what they're doing is they're using statement 5 to justify subtracting that from each side to get to statement 6. So this is just subtraction, property of equality. And then they are, once we know that 1 and 3 are equal to each other, look at how 1 and 3 are related. Angle 1 and angle 3 are corresponding angles. And so now we're going to use the corresponding angles postulate to say that the lines are parallel. So if corresponding angles are congruent, then the lines are parallel. So that one was even more involved than the previous one.